Hi, this is Taewei Wang. This lecture is a summary of Chapter 9 from Spurrier and Toppy's System as a Design book. The topic in Chapter 9 is about architecture design in the context of system as a design. This can be considered the first chapter that emphasizes more on design than on analysis. Specifically, we are looking at a very high-level design or high-level view of system development in the view of, say, for example, CIO or top management. So from the textbook framework, or you can call this even an architecture framework, that we are in a initial stage of design in the whole process or whole phases of system development. It is extremely important because the decision in architecture selection actually impact all the subsequent development effort and process, including the cost of any system development. So it is not a day-to-day decision that you can make, but once you have select the architecture framework, the impact will be quite long. And for most of the smaller iteration or so-called smaller scrum or sprint in an agile methodology, technology selection or architecture selection becomes sort of a constraint or an environmental issue for the current system or project you are facing. One classical example will be once your organization have select to use a certain enterprise information system. Say, for example, if your organization is an SAP house, a lot of this technology decision, selection of software, and what kind of interface you can build in between are all limited and constrained by your enterprise system already. There are, of course, outside of your architecture framework, or you can adjust your architecture to fit into a new technology or new problem, but that decision on enterprise information system has already determined a lot of follow-up selection that you have in smaller iteration or projects. And your textbook render a lot of definition for the term architecture. Among all these that you can see on the slide here, I like the last one the most. It's coming from Fowler, that he was considered one of the guru in the field of design pattern. And he said that the software architecture is a set of decision, and I emphasize on the word decision because it is a set of decisions that that we made that have a long-term impact in the design decision. And so these decisions that are both important and difficult to change after initial decision is made. And also pay attention to the word that he selected to use. It's called the software architecture. And it is different from hardware architecture or so-called network architecture that we usually refer to as architecture selection. But software architecture is actually much more important because in most of organizations today, investment in software is much higher than the investment in hardware and the network communication. So when we start to get into the discussion of architecture design, it is also important from the previous slide that you learned that Martin Fowler that he emphasized on the term software architecture. Here that you have to be very careful when you talk to people or listen to other people's conversation. When they mention the terminology architecture, you have to decide it on or actually make an important judgment on what are they talking about. If you make the wrong assumption about their architectural decision, the consequence is very disastrous. I should say that. So in a very high level view of architecture, we usually use a term called enterprise architecture. And based on this open framework of architecture, you can see there are four different terms that referring to architecture. One is business architecture, the second is data architecture, the third is application architecture, and finally you have technology architecture. Now, before we move forward, and let's take a look at all these four different so-called architecture aspects that has impact on your decision, and examine a little bit further. If we take out the first one is business architecture, and take a look at the other three, you will notice that these three actually sort of coincidentally that mapping to what we have learned earlier about the basic system component that we can analyze. That is data, process, and interface. In data architecture, talking about how do you handle the data management. And application is describing how do you build system software that can handle the business process. And so application architecture is actually a process architecture. And finally, technology architecture usually refers to a network communication. It is actually the foundation of interface decision. Again, it's not user interface, it's interface for all the system. It could be user to the system and could be between two server from database server to the process or application server to web server. These communication decision made up of this technology architecture and can be considered the interface architecture that we are talking about. And so this is why that earlier that we have emphasized both on the textbook as well as our lecture, we try to look at any information system from three aspects: data, process, and interface. And also we learned from previous assignment that the Zachman framework was used as one of the very important framework, and we don't call them any methodology. It is a framework to describe how all the components of these system analysis and design deliverable put together become a final implementable solution to the organization. As we have already discussed and probably discussed and test in the exam as well, is that you can also see the clue of the three important components in the Zachman framework. The first column in the framework, not the model perspective column, but the data column, is the data perspective. Second function is the process perspective. And we also see the network. And the other three there, you see the people, timing, and motivation. Those are the business perspective. So you see the similarity and the different way of classification, but they all ends up with a similar category. It's just that from the person interpret the basic view of information system, they have different way of classifying in different level of details. And from the top to the bottom, you see that it has a very strong project management oriented idea. You start from a top management, from big objective and goal, and slowly narrow down to the owner of the system and the designer of the system. Finally, you have the programmer, the builder of the system, and maybe the outside contractor that going to the contributing to the project. So that made the overall like a bird eye view of the system very easy to understand or classify. And this is actually the power of a framework, and this is something that you come to university and learn and try to think critically. And a lot of time we try to tell people that one of the skills that we have from the higher education environment is critical thinking. And how do you become critical? And you need to have a method. It's not that you know a lot so you can sort of like deliver them into somebody that you don't know about those facts. We have to go one level higher, one level abstract to the next level, that whenever a new phenomena come to us, we should have some sort of a mechanism to analyze again. And analysis is the job of go into detail. But the question is, how do we go into detail? The framework gives us a very good foundation to go into detail. Because every time you try to use a framework to classify concept, to classify problems, and you can actually go into more detail. And each one of those detail has a reference point that you can take a look at and think about more. And this gives people actually this is something what we call systematic way of analysis, because your analysis, your breaking down of the system is not based on random thoughts from your head. It is based on a framework that is already being tested and be verified by many other designer and system developer. So the Zackman framework can be also seen as an enterprise level, higher level framework we use to discuss architecture. And when we discuss, say, for example, the network column in this particular framework, we will be talking about technology architecture. When we look at the data column, you're looking at the data architecture there. So this way you can combine or actually merge these framework thinking from the Zackman framework to the other framework. So the open group architecture framework is again very similar to the Zackman. Is actually simplified. Personally, when we discuss architecture concept, I would be prefer to look at the open group architecture framework. The main reason is it's simpler. The framework itself has only 4 categories. When you try to divide the category into too many detail, that is important for more sort of like a smaller, smaller, much detail level of work. Say, for example, you're writing a computer program. But when you are looking at the big picture, like most of us coming out of business school, we will be in a more higher level decision position. In that case, we need to look at a higher level decision and smaller framework, less category is probably a better way to for us to manage the concept we try to deal with. And 4 categories is actually a pretty good starting point to consider. And if you look at the Zackman framework here, and on the vertical side, we have 6 different columns. Horizontally, we have 1, 2, 3, 4, 5 different row. Actually, the most updated the version of Zackman model has 7 column and 7 row. So this 6 column and 5 row give you 30 categories. So 30 category is actually outside of the human brain handling capability in the short period of time. So that is not a good tool, especially when we are trying to manage a very complicated phenomena or situation or problem. This will further complicate the situation. And at higher level, the open group architecture framework is probably better. That is my personal opinion. And you can also see there are many other different enterprise architecture models being proposed, but most of them are not as popular as the Zackman and the open group architecture. And a newer architecture model like this one, the Kutovzet enterprise architecture, actually provide more details and more implementations recommendation, but it become more complicated. And it coming from a one-dimensional or two-dimensional model to a multi-dimensional model, and that is harder for us to follow and to implement. But if you read the details of what the model recommend, you can still see there are similarity in terms of looking at the system development from the business perspective first, looking in the middle part of the tiles here, and then spin off to other more detailed technology architecture or data architecture or process architecture or functionality architecture framework that you can see in other different framework. From a information technology or system development project perspective, architecture decision, if it's already been presented in your organization and it will spin off to become something else, that something else will be, I used the term constraint earlier when I started the lecture today, but it also can be described as the requirement that you need to consider when you are developing your new system or new function. And this actually go into very importantly a category of the requirements called a non-functional requirement. And consider non-functional requirement, there are many category and aspect as well. And I will recommend that look at this little framework called the FERPS Plus framework. In FERPS Plus framework, it represents 7 different, 1, 2, 3, 4, 5, 6 different category of non-functional requirement. Actually, one of them is functional requirement, but we'll exclude that particular category. 5 different category of non-functional requirement. All these non-functional requirement intertwine with the architecture decision become an important constraint to your system development technology. For example, and let's use the UPS delivery system as one example. So nowadays we see a lot of this UPS deliver truck, and the driver will take one of this signature pad or something that keep track of all the package and the reception of the package in the process of delivery. So have you ever think about why that they are using that particular pad? Why don't they just use a cell phone, a company issued cell phone? And well, obviously cell phone will be much smaller and easier, and if you implement a software on the cell phone, it can achieve almost the same functionality as the writing pad or the so-called UPS. I don't know what we call that, but that device over there. And it is actually has been determined a long time ago when the UPS was forming their supply chain around the country, around the world. They already have that infrastructure in place. So the architecture is already there. So a lot of following up decision have to base on that particular requirement or the decision. So that become a non-functional requirement when we are looking at in new function development here. Say, for example, one of the non-functional requirement will be because we are using this device to keep track of the signatures and to track the package, and this device does not have a camera. So one of the non-functional requirement will be we cannot use camera to scan any code or to take a picture of something, and that become a constraint or requirement for your new feature. But of course, this kind of requirement, when you accumulate to a point that you have to make another architecture decision to get rid of this device, and that will be something that we see in the future, that you have to make a higher level UPS worldwide decision to change every delivered driver's checking device into cell phone application. So that will be the thing that use as an example. You can see how a architecture decision impact a smaller project that you might be want to implement or experiment in your day-to-day project and the new function that you want to try. So to summarize, non-functional requirements are usually come out of many different perspectives, and one of the perspective is architecture decision. In a lot of architecture decision, if you look at this FERPS Plus and that the category, it's coming out of a human decision. Human could be very political. Say one of the decision may be that why you are using the Android phone instead of iPhone for your communication network. Well, maybe the boss is a Apple hater, so he decided that we're not going to be using Apple, so everybody use Android. So that could all become an impact into the system development requirement. And in a way that the architecture decision can also be called a big design upfront or big decision or big function requirement upfront type of a requirement. So this is a big design upfront sort of decision that we're making is that your architecture decision has already been defined for you. So you have to use that particular design to continue your project. And one of the most popular terms, or actually the default term when we talk about architecture, is the technology architecture. As I mentioned also earlier, technology architecture is referring to the network communication. It is referring to the thing called client, server, operation system, software, and so on and so forth. In the context of system development, which is the context of system analysis and design here, we usually talk about software architecture, not the technology architecture. This is where that create confusion. But technology architecture is specifically select to describe, including network architecture, describe all the architecture we talk about in an organization environment. And typically, architecture is documented and communicate through a model or diagram. And this model you're seeing here is a very typical diagram for a component, how they collaborate with each other in terms of the physical network communication architecture. And in UML, which is the tool we select to use in this course, usually we use a tool called deployment diagram to describe this kind of software, which software install on which server. And the deployment diagram become the architecture diagram in UML. And more, due to the new development of architecture technology, especially the current trend of moving everything to cloud, it becomes more and more difficult to describe the physical architecture of your organization, because a lot of these services and architecture is actually going out of control from an organization, which is actually a good thing, because we no longer need to make decision about the technology architecture. A lot of these technology architecture problem can be outsourced to the cloud service provider. And traditionally, when we talk about our technology architecture, you will be talking about this OSI model, and you also will be talking about this TCP/IP model. Well, it's actually a better term for that is internet model. So OSI layered model or TCP/IP model will be discussed in our telecommunication and network communication courses. And that part we will not elaborate, but just let you know that these are the architecture decisions that you're going to be making when you are looking at the non-functional requirement in the software development project. And figure 9.8 here is just to describe the comparison between actually the usage of internet architecture, internet model, so-called TCP/IP model. How does it work from a personal environment to a server? And typically in the network communication course, you will be introduced to the development from LAN to MAN to WAN to the cloud or mobile network architecture. And your textbook actually give you a pretty good overview about the difference and complexity of these architecture. Actually, throughout the history of network communication development, this model become more and more sophisticated and complicated. And the general pattern is that you see more and more layers are introduced into this model. So traditionally, you have this mainframe model, very simple. You have a server and a client, and the user will be using the client. And when you go into more like a three-layer design or three-tier design, because the operation of organization, it become more complicated. People feel the need to back up their data, so they separate the data based into a new layer, and that become a three-tier model that usually introduced as the foundation of network communication course. And sometimes you will see that in the database course, you will learn that the main incentive of DBMS is to separate the data from your application server so that you can make sure your organization will not suddenly crash when your information system crash. You can always make backup of your data, so when the system crash, you can always restore the data when necessary. And from the design perspective, you have to understand how your organization software collaborate with each other. Are you using a different type of collaboration mechanism? And these are also discussed in the software architecture design. And one of the interesting, you can say, component that in all the software architecture decision is the thing called in the diagram or figure 9.10 here, the author called them services. And it's actually in different places has different name. Sometimes we call them middleware. Sometimes we call them protocols. In the Unix environment, we call them daemon. These terminology describe actually the intermediate communication services that you allow communication of heterogeneous or different system want to talk to each other. So there are many different way of system talking to each other. For those of you who have database training, the effort of using SQL language to provide a service so everybody can access the same thing is one of the effort, and that can be considered this thing called a monolithic view of software architecture. So the effort is providing a common language so everybody can use as an interface to talk to database. But unfortunately, in today's environment, that is not possible. We have many data sources. Say, for example, if you want to use the social network, looking at the Twitter and try to use Twitter data to do some sort of marketing analysis, those are not traditional SQL language, and then you have to use other way of query the data. And in that particular regard, the service is software as an architecture, or the so-called microservices will become a more feasible way of doing such job. And more complicated today in the environment that we have something called a cloud-based service. And a cloud-based service offer different level of the infrastructure service that you can select from. Some of them are very simple, simply move the data to the cloud. Some of them move even more the software to the cloud, and some of them offer the computer to a cloud, a virtual machine. And so this spin off as three different dominant type of model organizations are selecting. One is infrastructure as a service. The second level is a platform as a service. The third level is software as a service. Infrastructure as a service is a simple way of looking at the architecture decision. Basically, you are moving the physical devices to the virtual environment. So when you implement virtual machine that everybody can access through a virtual environment, that become infrastructure as a service. When you move up a little bit more, then you have the development platform into the cloud that become the platform as a service. A lot of these no-code or so-called low-code environment are a platform as a service. And finally, you move everything to the cloud and offer so-called like a black box type of service. So, the most typical example will be Salesforce. So when you subscribe your organization's information system to Salesforce, they pretty much do everything for you, including the software development. Whenever you have a requirement, they will try to develop. That become a software as a service, become the highest level of sort of like outsourcing model in the software design world. And one of the most important architecture decision in today's world, I'm referring to as the big data or artificial intelligence world, and data becomes more important than the software itself. And data resources become important decision to make. So when we look at the data architecture, and this become important that you have to realize and understand how today's data are acquired and processed and managed in different environment. Figure 9.11 give you such a category. Basically, it divides the data into two categories. One is relational database for from traditional realm, and you have the so-called data lake from the new so-called the big data era type of data, not structured, unorganized data, and you have to find a way to make sure these data can work together, and how you make decision is impact on how you select your software or service or architecture to handle this type of job. And this is data architecture design. Application architecture is easier to understand. Well, we basically look at how each function of different software program working together with each other. Again, in the UML world, they have a designated diagram used to describe this. Earlier, we talked about technology architecture was used or introduced or document in deployment diagram. In the application architecture, in UML, usually the so-called component diagram or so-called the package diagram will be used to describe application architecture. And this is a variation of the component diagram, and you can see the arrowhead describing the dependency of each component to each other. And from the overall concept of how UML diagrams or model try to utilize this type of diagram, you can see that the use case model that we have learned earlier in the course is used to modularize the concept, and the component or so-called application architecture diagram is used to conceptualize the physical software code or module that working with each other. They are related, and actually a good tracing program can keep track of how these software components can satisfy the use case model earlier we did discover and discuss in the system development process. Finally, when you are looking at the architecture, which is a longer term sort of decision in the organization, IT decision, that you have to periodically think about how do we change your architecture if it's necessary. And again, for smaller project, you usually won't change any architecture, but long-term wise, you have to think about how do you migrate or change your organization into a new architecture to fit the new business problem and new technology that come into the environment. Your textbook actually present a very nice model called the time matrix, and this matrix divide the technology or architectural decision into four categories. Depends on how much it contributes to business value and how much that what is the condition of current technology that you are using, and classify them into four different quadrants. And so you have something that you need to invest, something you want to migrate to, something you want to consider eliminate in the long run, or something that you can tolerate so far, and maybe will change later in the future. So periodically, especially during the strategic discussion in any IT organization or CIO meeting, and you have, say, for example, take out this model and take a look at the inventory of your architecture, technology component, and map them into the this particular matrix and make appropriate assessment so you can make much better infrastructure decision or architecture decision in the future. And that will be the summary of this particular chapter. And I hope this will give you some enlightenment about how we take a look at the architecture and at a higher level view, not just to discuss at the lower level, say, oh, this is a technology in the future we're going to be adopted. No, you have to look at this in the overall, more like a holistic view to make that particular decision on technology selection.